Okay, so earlier I took you through the textbook and the 7-step hypothesis testing project that Oris introduced us to in chapter 9, and we went through the 7-step hypothesis process with this light bulb example that he introduces to us on pages 155 and 156. Now we're going to look at it on the whiteboard here in a slightly different fashion. So first, they drew a sample of 10 light bulbs. Okay, light bulb number 1 lasted for 2,023 hours. Light bulb number 4 lasted for 2,236 hours. We see light bulb number 8 lasted for only 1,942 hours. Our interest here, let me remind you, is they have a new device that supposedly helps light bulbs last longer than what they're advertised to last. And these light bulbs in this example are advertised to last for 2,000 hours. So if this device is effective, then the average number of hours that our sample of 10 light bulbs lasts, the average number of hours that they last should be statistically significantly more than 2,000 hours. So that's really what we're doing. We're going to compare an observed mean for these 10 values here, okay? So we're going to compare the observed mean for these 10 values here to the advertised or the hypothesized mean of 2,000 hours, okay? And that's why you see this question, does the device extend the life of these light bulbs beyond 2,000 hours? So I did descriptive statistics in Megastat. Obviously, our count for how many light bulbs we have is 10. The mean life for those light bulbs is 2,000 hours with a sample standard deviation of 96.25. So there should be nothing unusual or controversial about that. Now, we go here and we look at mu equals 2,000 hours and mu is greater than 2,000 hours. Let me explain this real briefly once again, okay? Mu is the population mean, not of the 10 light bulbs that we just tested. Those would be X bar. The mean of those would be X bar. Here our interest is in the population mean of whether the average number of hours that the light bulbs last with this device would be equal to 2,000 hours. In other words, the device is ineffective. Or if the device is effective, then the light bulbs will last for more than 2,000 hours. Okay. The last thing in terms of the setup I want to take you through is, again, we see alpha equal to 0.05. That means we're willing to tolerate a 5% likelihood of a type 1 error. And you need to go back and look in chapter 9 to begin to understand what a type 1 error is about. Essentially, a type 1 error is if we reject the null hypothesis based on the data, when in fact, which would mean that the device is effective, but if the device really wasn't effective, maybe we just happen to have an unusual sample that led us to that conclusion. And so that's a type 1 error. Degrees of freedom here, again, our sample size is 10 minus 1 gives us 9 degrees of freedom. And I showed how we can look up in the textbook on page 377 to find the critical t-value of 1.833. Okay, so this middle part of the whiteboard is the setup, and then we go to the actual calculations. The observed sample size, as we reported, was 2,090 hours. The hypothesized life of the light bulbs at this point is 2,000 hours. And then you see our denominator is just the standard error of the sample, which is S divided by the square root of n, and our sample standard deviation is 96.25. Our sample size is 10. So we insert the numbers 2,090 minus 2,000 divided by our sample standard deviation of 96.25. Square root of the sample size is 10. Gives us an observed t-value of 2.957. Okay? Now, the first thing that we do in deciding whether we should reject the null hypothesis or fail to reject the null hypothesis is we compare the observed t-value of 2.957 to the critical t-value of 1.833. And since the observed t-value of 2.957 is greater than the critical value, that tells us to reject the null hypothesis and conclude that this device was effective and the light bulbs actually last statistically significantly more than 2,000 hours. And that should be what I say here. Since the observed t-value is great, observed t-value 2.957 is greater than the critical t-value of 1.833, we reject the null hypothesis and conclude that bulbs last more than 2,000 hours. Now the next thing that I'll do is I'll actually take you through the same problem, except we'll work in Excel and Megastat so that you can see what the process is for that.